In this video, we present the results from our work on using a joint attention metric for automated editing. To provide a quick summary, joint attention refers to the idea of finding focal points in an environment that are most salient, that is, attracting most attention from its occupants. Joint attention can be indicated in the form of head and body motions. People tend to look at or face what they find important. Audio is another indicator. A person or object emitting the most sound in an environment is also likely to draw attention. With the rise of smart multi-camera environments, group activities in conferences and events can now be captured from multiple viewpoints within the environment. In live streaming or replay post-event, however, processing the large amount of audiovisual data is both time and resource consuming and requires expert knowledge. To address the challenge of automated editing in multi-camera environments, we propose a joint attention metric for 3 automated editing methods. We use videos from the OpenAMI database, which features over 100 hours of discussions in smart meeting rooms equipped with 7 cameras from different viewpoints and individual microphones for each participant. We first asked an expert film editor to provide an edit of 3 meetings based on the definition of joint attention, to select the camera that shows the most salient viewpoint in the room. We use this expert edit as the ground truth to compare against. Here's an example output of the human expert edit.
My opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible, because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up.
The first editing method we developed is audio-based editing. As the name implies, this method selects the camera stream showing the participant whose microphone is emitting the most sound. It is the most common method of current commercial video conferencing software. We use the audio-based edit as the baseline for comparing automated editing methods. Here's an example of an audio-based edit.
My opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible, because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up.
Our second method is a rule-based edit. The method follows a fixed rule to rank the camera streams that show the people or objects that most people are looking at, based on estimated head pose from extracted pose data. Audio data is not used. When a participant has not been shown for a long time, their importance increases too. The pacing is smooth to be between 4 to 7 seconds per shot. Here's an example of a rule-based edit.
Opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible, because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up, I can just use my voice.
The third method uses a long short-term memory neural network, or LSTM, to predict the joint attention of the room. We train the LSTM using the expert edits of the videos as ground truth, with estimated head pose and audio amplitude as input. A simple algorithm then selects the camera stream each second that shows the people or objects with the highest predicted joint attention values. No pacing or smoothing was added. Here's an example of an LSTM-based edit.
Opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible, because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up, I can just use my voice.
And I'm the The industrial designer. Okay.
Yes.
Because I don't know you very well actually.
I am
but,
Matthew.
Okay. Mild. Happy to meet you.
Anna.
Okay.
And,
It's very.
and,
And I'm Nana.
oh, Matthew. Yeah. I think you know me, yeah?
Yeah. Just on your webpage, but yeah, not
Um,
face to face. So.
Are
So,
there some other very important?
Okay, and now I'm supposed to.
I have one question. Will there be anything written on the buttons, like that people know, or they have to learn that from a piece of paper which button does what?
Yes, it will have, these buttons will have the numbers and all the rest of the buttons will have symbols.
Will have symbols
Yes,
so that
Yeah.
which can be easily
that the user
recognized.
really knows,
Yeah.
you know, and
Yes.
doesn't have to
Good
first
point,
learn it.
because we need the
Yes.
symbols, because we're going into an international
And also-
market. We can't have
yes.
anything that's language
Yeah.
dependent.
But
The edits were compared in terms of editing quality against the human expert edit, and also validated through a user evaluation. Compared to the human edit, the audio-based method only showed close-ups of individuals, and the rule-based edit had a steady pacing that was unable to adapt to quick exchanges between individuals. The LSTM method was most able to mimic the variety in the pacing and camera streams of the human edit. In the user evaluations, we found that while users still preferred the human expert edit over the automated methods, both audio and LSTM-based edits had a comparable performance against the expert edit, and the LSTM-based method outperforming pure audio in pairwise comparisons. Generally, rule-based edit was least preferred. This shows how joint attention combining audio and head motion information can be used as a lightweight metric for automated editing in multi-camera environments.